Okay, so before I move on to the lowest point, let me tell you something about the highest point that I forgot in the video. So the normal force at the highest point, the normal force is always down and can have any value from 0 to whatever. All right, so what we found is that the normal force plus the force due to gravity equals mv squared over r. So depending on the speed, the normal force can be extremely high. Okay, there's no limit, limit to how big the normal force will be. There's no limit. Okay, it can be from 0 to any value. Now let's go to the lowest point. So the lowest point, so that was the highest point, normal force and gravity adding up to create the centripetal force. At the lowest point, the situation changes. So still, this is the radial axis. We have the force due to gravity down, and the normal force now is up. And the centripetal acceleration is up, not like here. That means that the normal force has two jobs to do. It has to cancel gravity and has to play the role of the centripetal force. So what we have here is, let's call this the x-axis. Again, the sum of forces on the x-axis 0. We consider no friction or anything else. The sum of forces on the radial axis create the centripetal force. Now, if I consider this direction to be positive, this will be negative now. So what I have here is that the normal force minus the force due to gravity should create the centripetal force. All right, so this is the case now. Now, even if the speed becomes 0, the normal force still has to play the role of balancing gravity. So in this case, we see that the normal force can be no less than the force due to gravity. So it has any values from from the force due to gravity, so the normal force will be, the lowest value it can have is the force due to gravity, and the highest is the force due to gravity plus mv squared over r. So again, there's no limit to how high it can be. Actually, I should have an equality here, right? I think it should be equal there.